we're going to learn about objects. And so let's take a look at our slide again. Oh, it's not coming up. There we go. So if we take a look at our slide and we copy out that piece of code, the whole segment of code that's in the slide here, and we throw that into processing, and processing crashes, then we open processing again, and
Oh my god.
once it opens again, we'll try pasting in. There we go. So we've got our code here from before. Can everybody see my text okay on the screen there? Anybody want me to make the font size a little bigger?
Yes.
Yep, okay, I'll make the font size a little bigger. Oh yeah, we'll make this like 18. There, how's that? Okay, so just like before, we have 4 segments to cover. First, we'll look at the class. So we have the class of apple, and I called it apple. I could call it pineapple if I wanted to, but then I'd probably change the color of it. But I'll leave it as apple. And the very first function has to be called the same as this up here. And we're going to call that apple, and we're going to say we need an x position, a y position, an x size, and a y size to make it, to be able to make an apple. And then we store those into the internal memory that we see here. These are the memory inside of each apple. And if we wanted to, we could also set the color, but right now we'll leave it as red, just so that we can start on a simple level. So before we got to this part, we've been doing projects where we don't erase the screen, so we can keep the previous things on the screen. What we're teaching you today is going to make it so that you can make dynamic backgrounds that stay the same, and then you can clear the background with the background command. So for now, we'll just leave it like this. We've got the apple, x, y, and size. And we've got this void render that I made up that sets the fill color, removes the outline, and draws a circle at the position we tell it to. And then up here, we've got a new apple, my apple. We made that up. And in setup, we fill it with an actual apple object that we made. So when we run this, with width divided by 2, height divided by 2, 100, 100, what it's doing is, for that apple, it's setting the x to width divided by 2, the y to height divided by 2, the x size to 100, the y size to 100, and then it stores them inside that apple here. Then we go up back here to void draw, and we can see we're going to do a black background and put the apple on the screen by using render. So when we run that code, for that apple, it's going to run this code. It's going to set the fill color, it's going to remove the outline, and it's going to draw a circle. So let's run it and see what happens. Alright, that's a little bit too large. We're going to make it a bit smaller, 640, 480. And there we have it. In the center of this screen, one red apple. So if we wanted to make another apple, we could call this my other apple, and we'll store where it's going to be. So my other apple is going to be a new apple, and we're going to put it at 25, 25, and make it 50 by 50. If we run that, maybe I made it, oh, so the reason why that didn't draw, I have to do this, my other apple dot render. There we go. So we have two little, yep.
Can you just like slow down just a little bit?
Well, it's going to be on video, and we only have about a half hour to cover quite a bit. So this is kind of one of those things where you're going to have to come back to it in the video. But if you have a question, I can cover that. I just can't help going this pace otherwise. Sorry, it's a big topic. I mean, we'll come back to it when we get to array lists as well. I mean, it's going to show up in every example after this point as well. But I guess what I could do is demonstrate again what I did. So to make a new apple, I'm going to give it any name I want. Does anyone want to pick the name for this apple? Throw a name out there.
Granny Smith.
Sorry?
Granny Smith.
Granny Smith, okay. Granny Smith apple. Actually, we'll just call it Granny Smith. So we got one called Granny Smith. Where do we want it on the screen? Anybody want to say where we'll put it?
Top right.
Top right? Okay, so that'd be width minus 25. How big do we want it to be? Same as the other small apple, 50 by 50?
Yeah.
Okay, so 50 by 50. And right now we're not going to see it because we haven't drawn it. So what we have to do is we have to tell that apple to draw on the screen. And now we've got another apple. So I'm going to open this one up to the class. Does anybody want to tell me what line I'd put here to put another apple? You get to pick the name if you answer. Any name you want. Your name if you want to be in the history books of this class.
Brandon's gonna name that out.
Okay.
You would write apple, then orange.
Orange. Okay. All right. Let's confuse everybody watching the video. Good. All right. And how big is your apple going to be and where is it going to be?
It's gonna be 50 to 50 at the bottom right corner.
Bottom right? Okay. So this part here that I'm doing right now is math. It's kind of hard to explain why I do this, except for the fact that if I wanted the screen size to be able to change, I use width and work backward from that so that I can work in each corner of the screen. So 0, 0 is this top left corner right here. And then this corner would be width and 0. This corner would be width and height. And this corner would be 0 and height. So basically whatever size your window is, you'll always know that from here to there is width. And from here to there is height. So the reason why I use width minus 25 is because I go right to the edge, come back 25, which is right dead center of this circle, and then I draw a 50 by 50 circle, 25 down from the top. So you want the bottom right, and it's there, but it's not appearing on the screen. So what am I going to put in to put it on the screen?
Orange dot render brackets semicolon.
Let's try it. You were correct. So let's say we wanted to do something a bit more interesting than just a static object. Let's say we did this. We could go down to the class, and this is the part where I'll try and really cover it because this is the most important part of a class. Let's say I make something called void move x, and I take an x position in, and then I'm going to add that to the x position. So just by looking at this, can anybody tell me what I'm trying to do here? Not tell me exactly how the code works, just tell me what I'm trying to do. Anybody have an idea of what this piece of code would do if I were to run it? Yep.
Have the shape move around.
Yep. Yeah, it would move the shape around. By how much? It's kind of a trick question.
Just up and down. I don't know.
Actually, a better question, which direction, like what, would it move up and down or left and right? Almost.
Left and right.
Left and right, yeah. Perfect. So, anybody have an idea of how much it might move? This is kind of a trick question, so if yeah?
You haven't set it yet. Is X input the amount it moves?
X input is the amount it moves. So it's a new variable that I made inside of that function so that when I call it, I can send a number to it. So when I say apple.render, I could do this before it and go myapple.moveX. Did I call it that? Yeah, moveX. And then I can call it moveX and pass a number 1. And if I run that, it's going to move on its own. Nothing else will move. And you'll notice that it just goes right off the screen because there's no way to know if it went off the screen. But what if we made it smarter? What if we did this? what if inside of moveX we add some code that if xpose is greater than the width, xpose equals 0, and we run that. Now it comes back around. But the reason why I put it inside here instead of inside the draw is because now I can do this. I could copy this part here, the .moveX, and go my other apple .moveX, Granny Smith .moveX, and orange .moveX. And when I run it, they're all going to move and come back on the other side when they're done. But what if I wanted to make some of them faster, some of them slower? We could make my other apple move at 2, Granny Smith move at 3, and orange move at 4. And now you've got objects that move at different speeds. So they act unique, but they're still apples. They're still the same type of class. They run the same code. But because I give them each different numbers, they move by different amounts. So the point of the class is to make it easy to make a smart object that does what you want it to, and then copy it lots of times. Any questions about how we got here so far? Any concerns? Better yet, anybody see any point in doing this? Does anybody see a reason why they might want to do this for their project? Yeah. Clouds, yep, yeah, you could totally use this for clouds. Clouds that move at different speeds. And also, watch how easy it is to, let's say we want to make these look more like apples. What if we, instead of drawing one circle, we do the x position minus 5, and we draw another circle at x position plus 5, but otherwise still in the same spot and the same size. One extra line of code, whoop, I gotta make it a little bit bigger. Let's add 15. One little bit of extra code, and now they start to look more like apples. Can everybody see that they look a bit more like apples? Now watch this. Let's add a circle behind these. So we'll copy this no stroke out and put it up here. But we'll add something, another little circle behind these that's going to be green. And it's going to be at x pose, it's going to be at y pose minus 25, and it'll be 25 by 50. Huh, that looks kind of weird. Okay, that didn't work quite right. Let's do this. Y size and 10 and y size divided by 2. Let's see what that does. There we go. Yeah, it looks a bit more like an Apple logo, or something for a company maybe. But you can see that I'm adding more graphics to these. And okay, so yeah. Cooler is a variable we made up inside of this class. So it's something I gave a name to. If we wanted to, we could call it apple color, and then we just copy and paste that in there. Now let's say we have some really strange apples. We could do this. Apple color equals color random 255, random 255, random 255. Oh, there we go. If we run that now, each apple has a different color when they're made, but they're only set a random color once, and then they stay that color forever. It's interesting this one still stayed red. But yeah, so what you can see here is that you can make more and more complex drawings, but because we're using a class, you write that code once, and every single object after it is going to have that same shape, or if you do randomness to the size and stuff, it could be more unique. Yeah, so this makes like apples with exclamation mark leaves coming out of them, I guess. I don't know. But it's just an example of how you can make something look more graphical without worrying about all the extra lines of code to do it for each individual apple. You make the code to draw it once, you put it in a class, and there you go. You can make 100 of them, you can make 1,000,000 of them. Probably don't make 1,000,000 of them, that might slow the computer down too much. But you could definitely make 100 of them. So I promised earlier we wouldn't go too heavily into arrays, but I feel like we should, unless there's any questions right now. Last minute for any questions before we really go crazy with classes and objects. Anybody got a question, concern, idea? Okay. So let's make one array called myApples, but we have to tell the computer it's an array. And we're going to say equals new apple 30 for 30 apples. And actually we'll put that in a number. Int num apples equals 30. And we'll delete all this code here for regular apples. Maybe instead of delete, we'll do comment it out. So we're just going to make the new apples, and we're not going to worry about those old apples. Okay, so we make a for loop and start it from 0 and stop it or keep going as long as I is less than the number of apples, and add to it at the end of the for loop. And then we can do this. We can go myApples I equals new apple, random width, random height, and we'll give them a random size between 25 and 50. So just like that, we've got all these new apples stored. We copy paste that for loop. We're going to throw it right in here. And instead of any of this stuff, we just delete that end part, not that part. And then we go myApplesI.render. And just like that, we have 30 apples on the screen. But they're not moving because I didn't tell them to move. But now I can. myApplesI.moveX random 2 plus 1. And you know what? Let's make life easier on ourselves and just draw the regular circle again. Okay. So these are our abstract apples, and you can see we've got 30 of them. Well, you can't really tell, but if you wanted to, you could see it. If you paused it and counted, whatever, but we can change that number to 300, and we will have 300 apples. We can change that number to 3,000, and we will have 3,000 apples. We can change that number to 300,000, or sorry, I think that's only 30,000, and we will have eventually a whole bunch of apples. We can change that number to 300,000, and we will kill these computers if we try hard enough. Hey, that's pretty good. I'm proud of that. That computer's doing well. Okay, so yeah, and it's a Mac. You know, you got to cut it some slack. It's a Mac. Okay, so yeah, there's 300 shapes moving across the screen quite happily. And when they go off one side, they come back on the other. So if we wanted to move it in different directions, we would make a move Y, we would make maybe like a bounce or whatever you want to do to it. Those are just, the idea here is not to think of a class as a new way, like you wouldn't start with a class right away if you don't feel comfortable with them. What you would start with is, let's say, make a simple example, then make it work with an array, then move the core bits of code from that into little functions. Once you're comfortable with those functions, then you can start building a class out of those functions. And then you'll have this complicated thing that looks complex but is much more flexible because you can use it in different ways. You can make it do interesting things for each part. Now, I'm going to start a new class just to show how you could make a class. So we'll make a class called, what do we want to define? What do we want to draw on the screen? I'm leaving this one up to you, the class. Class. Okay, so any ideas? What are we making? What are we drawing? Anyone at all?
Clouds.
Clouds, okay. So we're going to call this cloud. It's going to be one cloud. What does a cloud have that we need? It's probably going to have an X position. It's probably going to have a Y position. What else would a cloud have? Any takers? Color, yeah, that's a good point. A cloud has a color. I'm just going to use a K here. Actually, I'm gonna advertise that Adobe thing. It's pretty cool. What color would a cloud be normally? Like kind of gray? Maybe 200? Oh, looks like when you're using color, you have to pass all three numbers. Oh, ha, that was the problem. Don't use the word new. Okay. So it'd probably be gray. Let's make it gray. We can see here it's kind of mad about something. Maybe we got to use a lowercase c. Okay, that's it. So don't use capital C with class. Good to know. So what else would a cloud have? Yep.
Transparency.
Transparency, that would be kind of part of color. So how transparent? Really transparent, a little bit.
I'm not really sure. I guess like
70? All right, let's throw 70 in there. How about size? Would a cloud have a size? Probably. So we could make an X size, and we could start them at 32 just to start with. So everybody feel happy with this? This is probably the right number of things to start with for clouds. So we have to make the function called cloud, and we'll take in an X position, so X input, Y input. We'll just take that for now, and we'll add to it as we go. So X pose equals X input, Y pose equals Y input. That would be the starting point for a cloud. Now, if we were to make a whole bunch of clouds right now, what's one thing we're missing to put them on the screen? Any takers? We have all these nice clouds. They remember where they are, but they don't go on the screen. Why? Render. So it could be called whatever we want. I'll let you pick the name since you answered the question. What are we calling it?
Draw.
Draw. Well, we can't use draw because that one already exists. See how it turned blue? What should we call it instead? Sketch. Let's try that. Yeah, we can use that. So we've called it sketch, and we're going to draw a circle. We're probably going to want to make sure we set our fill to our color. We're going to want to make sure there's no outline. And then we can finally draw our circle at our X position, our Y position, at our X size, and our Y size. And that's pretty much it for this class for now. So before we move on, any questions about this class? On the screen, the class code, not this entire course. Cool. All right, so let's make a cloud. So we're going to call cloud my cloud. And we're going to make our void setup, which has the basic commands of drawing or setting a size, let's say 640, 480. Then we're going to do our void draw, which is our every frame, and we'll make sure it has a nice blue background. So let's do like 50, 50, 255. Let's see what that looks like. A little bit too blue. A little bit too blue. A little bit too purple. Add a little bit more green, Karen says. Oh yeah, that did it. Perfect. So let's put our cloud, let's make our cloud. So we're going to go my cloud is going to be a new cloud at, let's start at the center, height divided by 2. And we only take an x and y, so we're only, right here we only take x and y, so we're only going to give it an x and y. And then we can draw it by saying myCloud.sketch. And if we run that, we've got our little cloud piece right here. So I'm going to make a whole array of clouds out of my cloud instead. I'm going to say my cloud equals new cloud 500. And you'll see here it's getting mad because my cloud is no longer just one object. So we need to do a for loop. I equals 0, I is less than 500, I plus plus. This is sort of like the standard formula. And you can see it's still mad, and that's because we need to do this. We need to add a little square bracket, type I, and another square bracket. And then down here we need to do the same. Go here. And then add a square bracket I, square bracket. So the same I we made up here, we use it down here. And they're all in the same spot because we've given them all the same position. So don't do that. We'll give them different positions this time. And now we've got 500 clouds on the screen. But let's say we wanted to do more. What we could do is replace that 500 with an integer, a whole number called numClouds, and make it 1000. And then we'll copy and paste it over top of every. Oh. There we go. Every 500. And now if we run it, we have 1000 clouds, or we can have 10 clouds. But these on their own don't quite look like clouds. So what we could do is draw a whole bunch of ellipses at random positions. For now, we'll do fixed, so they look like Mario clouds. So this would be like x pose minus x size divided by 2, and y pose minus y size divided by 2. And then this would be x pose plus x size divided by 2, y pose plus y size divided by 2. And whoops, that didn't do what I wanted. Minus. Starting to look a little bit like a Mario cloud. Maybe we'll add a few more. So instead of minus, we'll do a plus here and a plus here, and instead of divided by 2, we'll say divided by 3. Kind of looks like that cloud that the Koopa that throws little spike shells at you has. It's pretty basic. Let's make it a bit less transparent. Maybe even a bit less transparent. There we go. So we probably want to make a whole bunch of these. So what we could do instead is this. We could make our own for loop in here, and let's say we want to draw up to 10 things. Exactly 10 things. We could just draw an ellipse at x pose plus random x size times 2, y pose plus random y size times 2 by x size and y size. And then we'll get rid of all these lines down here by commenting them out. So now it's even more random, but the interesting thing here, can anybody tell me what these clouds might look like before I run it? Would they look the same every frame? Would they change every frame? Those are the two options. Who wants to raise their hand and say they will change every frame? Who wants to raise their hands and say they'll stay the same every frame? Nobody wants to raise their hands at all. except for, is your name Sarah? Okay. How do you, which one do you think it'll be? Okay. So let's run it and find out. So I'll tell you why that's happening. Because we're using random and this gets called every single time draw gets called, it's offsetting them each time. So what we could do here is we could actually put an array of x positions. Oh. So we could make an array, and we can't call them the same, but these would be like the f, or x, no. Basically, these are going to be like each individual offset for each little mini cloud bit, so we'll just call it like mini cloud x and mini cloud y. So what we would do here is we would take this code down here and instead change it to plus mini cloud xi and plus mini cloud yi. So this way they would stay in the same position relative to the center, but we need to make it that when they're created, we go through all of those mini clouds to give them a position. So mini cloud xi equals random width times, or x size times 2. Mini cloud yi equals random y size times 2. And now they have a value, and now they'll stay the same wherever they go. Maybe times 2 is a little bit too aggressive. We'll just take that out. But if I draw only one cloud, and it actually gets somewhere center of the screen, there we go. There's 10 little circles around this little puff of cloud, and they stay constant relative to the center of the cloud. So if you move that cloud, the x pose and the y pose, these two numbers here, if you move those, they would all move together consistently. But now they're made out of tiny clouds, like we can see down here. And just to prove that, I'll do this. And 70. So I made them do this just to show that there's different colors, different circles being drawn every frame. It's drawing 10 of them instead of just one circle, and it's drawing them around the center position based on an offset. And what we could do to make it more centered is we can do equals random x size minus random x size, and random y size minus random y size. So sometimes it'll be above 0, sometimes it'll be below 0, sometimes it'll be exactly 0. Each time it makes a cloud, they're going to decide on their own. So now we can go and make 10 clouds again. These are starting to look a little bit more like clouds. Maybe they're a little bit too far apart still. So we could do x size divided by 2, y size divided by 2, x size divided by 2, y size divided by 2. This is just really trial and error. You're going to play with the numbers until you find something you like. I don't quite like 2. Let's try 1.5 to make them just a little bit smaller. Still a little bit too spaced together, maybe just even 1.25. Okay, that looks more believable. Now they're a little bit too strongly colored, so what we can do is get rid of some of that opacity, make it more transparent. So that's starting to look a bit like clouds. And what we could do to make it look a bit more believable, we're going to set the fill color to some sort of green, let's say 70, 200, 150, and then we'll just draw a rectangle. We'll make sure there's no outline. And we'll make it go from 0 and height minus 100 to width and 100. Maybe a little bit taller. So there we have some clouds that are just staying static in the sky, and we're hiding the other ones down here with this fake grass. Now let's make them move. So can anyone tell me what command we would make to make them move? What would we call it? You get to choose. Nobody wants to name their own function? That's okay. I'll make one. Called void. Nobody named me. And then what we'll put in here is we're going to put the x position equals x position plus 1 for now. And if the x position goes off the width, we're going to just set it back to 0. Nothing's going to happen because I haven't called it yet. But up here where we tell them to sketch, we're also going to tell them to move by saying nobody named me. There we go. So right now this is pretty neat, but you see how it's jumping there? What we would do to get rid of that is instead we'd let it go a little bit past, like let's say plus 100, and then set it to minus 100. So it has that kind of like extra buffer off the screen, and it looks like it's a new cloud coming back onto the screen. So you'll see that when it goes through, and then after a little bit of time they come back. And that would be like an example of clouds. Now, we're hiding these clouds at the bottom right now, but it doesn't really make sense to put them there on the screen. So what we can do is this. We can say int ground level equals 200, because that's how high the ground is. And we'll replace the grass with ground level. And what we'll do here, where the clouds are being created, up here actually, instead of random height, we'll do random height minus ground level, because then they'll never be below the ground. And now all of them are going to be created in this top half, and I can prove it by doing this. If I hide the grass, there'll be none down here. But I can put that grass back, and now there we have it. We have these little clouds going by. We can make more clouds, 10 times the clouds. We could make it look like a normal day in England. Oh, wait. There's one thing I forgot about that. There we go, normal day. Oh. There we go. Normal day in England, pavement everywhere, and an overcast sky that's really making the system lag. So we'll put that back down to 100. So as you can see here, we've got these interesting objects. Like if we follow this little one that's lagging behind here, it's going to look exactly the same here once it comes back around here. There. Yeah, I was going to say, oops, it changed. But no, it's this one right here. And as it goes off the screen, it comes back looking exactly the same. And you can see there's this gap here. So what we could do here is do random width plus 200 minus 100, because we have this little buffer on the sides that we created. We can make it that those buffers are also filled with clouds so that there's never a gap in the clouds. And ideally, a cloud really wouldn't come this close to the ground unless you're like looking really far into the horizon. So maybe we'll also like take an extra 100 pixels space away so that they're more condensed to the top of the screen. So just by using a class, we've saved ourselves a lot of code, and we've made interesting objects that behave on their own. These clouds are self-sufficient. They don't need to know what other clouds are doing. And we can make each cloud slightly different by, instead of doing this little color command here, when we make a cloud, we could say color equals color random 50 plus 150, and 70. And now each cloud is going to be a slightly different color as a whole collection of clouds. It's not going to be each individual circle, but it's going to be each cluster of circles, which creates a more believable cloud. Maybe we'll increase that size to 64 by 64. Starting to look more believable. Anybody feel like that represents clouds pretty accurately for a cartoon? Yeah? So yeah, that's pretty much it for using a class with an array, making your own functions. I don't want to go too heavily into class-specific examples for every tiny thing that we teach because you don't need a class to do this. You could do it using hundreds of arrays, and not hundreds of arrays, but well, I guess if there's 10 clouds and each one has 10 mini clouds, you're looking at 100 different different pieces of memory of X position and Y position. So in a way, it would be like hundreds of lines of code if you tried to do it without an array and without a class. But just using a class, we've done it in much quicker time, much shorter lines of code, and it's much easier to tweak it. If we want to make each individual class look like each individual cloud do something interesting, we could write code that basically handles that. We could write code that says, oh, if we're at this position, shift a bit downward. If we're on this side, shift a bit upward, so it could look like it's going up and down. You could do things like that. We could give them variables inside to say, if the cloud was going this way and it goes off the screen here, it flips and goes the other way, but the other clouds would still go right. So basically you can make code, if you can make code for one object to bounce around, also grab it to me. If you can make code to bounce around randomly on the screen, you could take that into a class and make a whole bunch of objects that bounce around randomly and have their own booleans, have their own floats. The point of the class is to make each one act individually. It's good for games, it's good for art, it's good for computer programs, it's good for modeling real life traffic simulators, ants, like the tiny ant hills. You can make like million ants that all do individual things. Actually, there's a game where you control ants called SimAnt, and they use basically the same code concepts to make each ant do its own thing. But yeah, it's kind of something you have to do to understand it. I tried to teach it in a way that if you come back to the video, you can follow along with the video. But it looks like we actually have a few more minutes than I thought we would. So now's a good time to ask questions about class, because you do need at least one class in your project when you submit it. No questions?
Maybe you could talk about different ways that you could use classes.
So,
Or ask them how.
yeah.
Yeah.
So, how would you maybe use a class in your idea? If you have an idea, or if you just, like, let's say you knew how to code everything in the world, which nobody does, but let's say you did, and you were just worrying about what idea you want to make. What's something you would like to make a computer do? Do you want to make a game of some sort? Do you want to make an app for your phone that helps you with your daily routine? What's something you want to make, if you could make it? And I'll try and find a way to show you how classes could follow into that. What's something you've always wanted to be able to do with a computer that you couldn't do through the programs that you have access to? Like, maybe you wish you had a program that made it easier to like cut the backgrounds out of objects, or you had a program that made it so you could just put stuff on a screen and it would become a website without any worries about code. What's something you would make a computer do if you had the know-how to do it? Yep.
Can you make that game Pong with class?
Yep. So with Pong, you can make each Pong paddle a separate class, so that you just make the same code for each one, so it draws the Pong paddle that the player controls. And then outside of those classes, you could have, like, if this button is down, tell that one to move. If that button's down, tell that one to move. But they'd have the same code to move up and down. You just send them which player is pressing it, and then they would know to go up and down individually. And that way as well, they could know like which side of the screen they're on, and if the ball goes off that screen, they go, yep, I got a point. Like you can use classes for that example for sure. Anybody else with an idea for class?
Could you create something like an ocean with lots of waves in it?
Yeah. So if you made an ocean out of little sections of water, you could make each section a class, and then you could have it that, like, if the mouse is within that section, that little bit like causes like a wave of water to rise up and crash down. You could make, and another thing about classes, you could make one class work with like, you could make one class for an ocean wave, and then make it that when that ocean wave hits the other part of the ocean, it causes it to wave, and then it causes like a sequence of waves. I guess that'd be more like a crowd wave, where like if you're in a sports stadium, you make one person raise their hands, and then other people see it, and they go in order of raising their hands. But that's kind of how you'd use a class, is so that you can make a smart piece of code that can react individually to a situation. Like, let's say you're making, let's say, a maze, and you want to make something that goes in whichever directions it can, and you're making, like, let's say, a whole bunch of people going through this maze, and you want them to go, oh, it's a dead end straight ahead, I can turn left or right. But for someone else, it's open straight ahead and a dead end left or right, so they have to go straight. And you don't want them all to follow the same code. That'd be a lot of code to figure out a maze like that. But using a class, you can make each one do whatever makes sense to it. Basically, humans would be a class. If you tell humans to go to work, they all go to their different jobs because they're, as individual objects of the class human, they would have different jobs in society. Does that make sense a little bit? Sort of like let's say if we tell everybody here to take a 10-minute break, that doesn't mean we're telling all of you to stay in the lab or go to the other room right away. Each of you can do whatever you want. So even though you're all part of the same class of student in this course, as an individual, what's called an object or instance of a student, you have a free choice of what you want to do during your break. That would be if we were to program you as people, then we would just tell you go to break, and you would decide from there what you're going to do. So the class helps you define a way of saying, hey, all these apples fall by gravity, but some apples might be still on the tree so they don't fall. Some apples land on the box and roll. Like, basically the idea would be you tell it what to do, and it does the smartest thing it can in that situation. It thinks about where it is, you teach it to understand where it is, and then it reacts. It's a way of making code interactive. It's a way of making code intelligent looking. It's also a good way of checking if like two objects are going to touch each other and then say, oops, they bounce off each other instead. Yeah, a lot of for loops, a lot of if statements and functions, a lot of variables. You're pretty much, if you do a class in your project and you make something that you can have like 10 of on the screen, you're guaranteed to have your arrays, your classes, your if statements, your variables, and your functions. So you have everything you need for your project just by using one thing in a class that has 10 instances. Like this right here, this actually has everything it needs for a generative art piece, code-wise. Interest-wise, it's not very interesting. But if you were to add on top of this something interesting, that would be all you need. So does that make it seem a bit easier to get to this level for your project? Like, you don't have to make the next Mario, you don't have to make even Pong if you don't want to. You can make something like this, but do a little bit more interesting animation with it, and that would count as generative art. That would be like a screensaver for someone that misses MS Paint or something like that. Actually, I can show something here. Right now we're moving them one at a time per frame. But what we could do is we could give them a speed. And what we'll do is, whenever the cloud goes off the screen, which is happening right here, so we'll add plus speed instead. And whenever it goes off screen, we will instead set the speed to a random number between let's say 0.5 and 2.5. And now every time they go off the screen, they might go faster, they might go slower. That's more generative because it's something that every time you open it, it's going to look the same-ish at the start. Each cloud's going to be different. But they're all going to move at the same speed, and then sometimes they're going to speed up and slow down as they come on and off the screen, which also creates this interesting parallax effect. It gives it depth. It makes it feel like it's coming out from the screen. So just like that, it makes it look more 3D, at least in my opinion. So really it's about experimenting. It all comes back to break problems down into smaller problems, use trial and error, use problem solving approaches, critical thinking approaches to try and make something interesting first, make something unique first, and then come back to what you want to do for an idea. You shouldn't have an idea until maybe Thursday next week. But even then, that's pretty early. Like, you should have little experiments that you're doing and then come back to make that into a bigger thing when you feel more confident. So that reminds me to tell everybody, on Thursday we're going to come around, Karen and I individually. You'll have time to just work. I won't bore you with presentations, and we'll just talk about your ideas, help you come up with ideas. And if you have an idea and you feel like you can't do it, that's okay. We'll come over, we'll also just, hop on the keyboard and try things out. We don't know code, we just know how to use code. And I think that's the real strength of an artist using code, is that it's not about the code, it's about the art. Too many coders lose focus of that. They make the perfect code that looks really terrible when it's running because they didn't think about the design concepts. Like
for instance, the way the screen is divided up here.
Yeah.
It's the golden ratio in ways.
A little bit.
Or of thirds.
Yeah, it's about a third.
Yeah.
So.
And then there's variety and repetition and all the other things we've been talking about happening in that very simple sketch.
So you can apply grid, you can apply layers. We got layers and transparency. We've got framing in a sort of way. You've got repetition and randomness. Use your design concepts to make interesting things. This course isn't about who's the best coder. This course isn't about who's the best artist. It's about making interesting art that you're still learning the tools. It's to demonstrate that you've learned the tools, you made something interesting, you discovered something interesting, and you wanted to share it with us, and eventually use it maybe as a portfolio piece, or refine it after you graduate and make it into a portfolio piece. This is about showing us what interests you in code and design. And with that, it's about 2 p.m. almost. Maybe we'll do some any examples you want made for ideas you might have. We'll do them as a class on the screen, or if you want to work on your project, you can do that. I mean, basically, aside from the time that we're teaching and presenting, it's all up to you outside and inside of school to try things out. I can't say I can't say trial and error. I can't say experiment. I can't say see how it goes, wing it, play with it. Yeah, you gotta play with the code, because there's no way to learn all of it in the time you have. There's no point in learning all of it in the time you have, because there's lots of great examples that you could mess with, mutate, change. Just remember that when you're making your final project, you want to be able to write all that code not from like scratch, like a blank screen type thing, but you want to be able to write all that code, typing it with your own keyboard instead of just copy pasting. because we're going to look for that. We're going to look at your comments, and your comments will tell us how much you understand of what you're doing. We don't need you to say like, oh, this code here puts that variable into this part of the memory. We don't need that. What we need is this code puts a cloud on the screen with 10 little circles. That shows us that you know what you're doing to make each individual cloud. We need something that says, oh, give them a random grayness for the whole cloud. We need, oh, put the grass 200 pixels above the bottom of the screen. That's what we need. We need just some proof that you didn't copy paste it off the internet, that you kind of understood what's going on just through trial and error, just through experimenting with it, just some way of knowing that you had fun in what's probably not that fun for a beginner at code, but you still had tried to have fun with it, tried to play with it, mess with it, like throw it in a blender and see what happened type thing. Just mess with the code. That's my best advice. That's the way that I learned. And don't feel like what you're making is bad, because I know like the things I made when I started code, I probably wouldn't show it to an employer, but it's good to show it to your friends for a laugh. Like, make things that you think are weird, and then figure out how they work. Don't worry about, is this going to look like art? Because nobody knows what computer art is supposed to be. It's supposed to be art made on a computer. And if you look at the art industry, nobody knows what art is anymore. It's no longer decided by some sort of elitist group. Art can be anything you do. Pretty much anything you do except...
Anything creative.
Yeah, I mean, you could even say tax evasion is an art.
Yes.
And legal loopholes are an art. And scams that actually work are an art. Hackers are art. Like, unfortunately, it's so vague we can't tell you what to make. But anything you do is pretty much art. When you choose a mismatched pair of socks, that's art. When you choose to keep wearing a shirt after it's ripped, that's art now. That becomes an art form because you made a conscious decision to do something different from what was given to you. You're using something given to you, which is processing, to do something you decided. That is art. To me. I should add that little clause.
Now that we've talked about playing, I want to make you guys refocus for a second. Because something that came up in the last grading that we did of your last project on the websites was simply following the instructions was a problem. And not producing and handing in the things that were actually required. And simply following the instructions of what was needed for the final input of your projects. For instance, the fact that many people didn't hand in the PDF and PNG part of it, or didn't hand in all the original artwork. Those simple things lose you grades. So look back at the instructions before you hand in and make sure you've ticked off every single thing that's expected of you. And the chances of you getting a really good grade go up just by doing that.
Yeah.
So play, break the rules, have fun.
Just make sure to submit all your files. And with code, it's a lot easier because even if you use external images, just make sure it's all in the same folder as your code. Zip that whole thing up and send it to us, like on Avenue Learn, because luckily it's only one file, your processing file, plus whatever graphics you have. There's no working files needed for this per se, except for code and final images and final sound or whatever you use in your project. You don't have to use sound, you don't have to use images, you don't have to use vectors. You can do it all in pure processing. Just make sure that you submit everything you need so that when we open it, it runs. Because if your code doesn't run, I don't care about if there's pieces of it that don't work that you've commented out, or if there's pieces of it that do work but don't really do anything on the screen. The most important thing is that when we extract that zip file you send us and open it up, it runs. It's sort of like with the second project, if the website didn't open, that was the biggest part of that project, was making sure that you displayed your content, because if you can't display your content, we can't really mark it properly. So it's the same way here. If your code doesn't run, we can't mark it. So play with it,
Yeah.
break it down into small pieces, and then figure out how to put it together, sort of like reverse Jenga, and then basically make sure it runs. It's okay if there's pieces that don't get used, if there's pieces that are commented out. Just make sure it runs.
Good test. Send it to one of your friends in class and see if they can get it to open before you submit it to us. Always a good check. Eh?
Yeah.
Yeah.
Or just
If they
copy
can't
paste it
do
to a
it-
different computer.
Yeah, or yes, that works too. I just noticed something. I got an email up here, and evals are out, so you can evaluate your course. I recommend that you do so.
Yeah.
Feedback is always good for both TAs as well as instructors, so please do that. It's important to all of us. Everybody wants a better course.
Yeah, and that has no correlation to the Timbits. Those were brought in because we knew we were covering a tough subject today. So eat 5 Timbits, and then don't think of them when you're doing your evals. But definitely eat them all so that I win a bet against Karen.
Yeah, okay.
Okay, so, yeah.
Looks like it's break time.
Okay, so yeah, I think that's it we'll probably do a 10-minute break now, and then you'll be on the other side. Feel free to email us if you have any questions individually. I'm going to upload this video right now. And also to make it a bit easier, what I'll do is I'll cover the same kind of topic with the other group and upload that video too, so there's twice the videos covering classes, so there might be complementary information in each one. Eat a Timbit. People are going to think I work for Tim Hortons.
I was wondering if you made graphics in Illustrator and then
Yeah.
put it in. The
There's
other person couldn't open it though, right?
I think there's a way to make the graphics in Illustrator,
by
and then
the
if you
way,
open them with like
by the
Text
end of
Wrangler,
these
you might be able to see the numbers, and then you can draw the lines in processing.
The end of the day,
But
so.
if you want to, you could also export it as a PNG, and then put it in the same folder with your code, and when you zip it up, because
It won't run?
yeah, it'll run, because you'll do it as a P image instead of a vector. So if you do it in Illustrator, you can either open it up and get the numbers out and draw the lines inside code, or do it as a PNG. That would be my best advice. But if you look on the Avenue Learn, Nick Bomarito made his with SVG vector formats, and it's an example under assignment 3. And it's just a little dinosaur that moves to where your mouse is, and it's got moving arms. It's really cute. But it's on Avenue Learn. It's N Bomber or something like
I
that.
think it's like easier to like make graphics.
Yeah. But you
But
still
we
want
won't
to
lose
make.
marks, right?
Well, it depends. See, if you just make a static graphic, that wouldn't show us.
They're moving.
Yeah, but if you made them move, and if you made them do something interesting, that would work. It's about making an interesting art piece out of code. So you could make the individual pieces sort of like a design kit of parts of vectors, and then just make them animate through code, and that would count. To me, that would count. Yeah.
Yeah.
Thanks.
That's a good idea.